A derivative is the limiting value of the ratio of the change in the function to the corresponding change in its independent variable. Today we'll be focusing on product and quotient rule. Product rule is defined as k equals f of x times g of x. K prime, or the derivative of k, equals f prime of x times g of x plus f of x times g prime of x. In English, k prime, or the derivative of k, is the first times the derivative of the second plus the second times the derivative of the first. The quotient rule is defined as k equals f of x divided by g of x. K prime, or the derivative of k, equals g of x times f prime of x minus f of x times g prime of x over the bottom squared, which is g of x squared. K prime equals low times the derivative of high minus high times the derivative of low, all over low squared. Now we'll be looking at product rule examples. For the first problem, you get f prime of f, or the derivative of f, equals 3x squared times 21x squared plus 7x to the third times 6x. Then you can simplify this problem and you'll get 64x to the fourth plus 42x to the fourth. Then you can simplify it even more for f of prime of x to equal 105x to the fourth. With the second problem, you have 4x to the third minus 4x to the fourth times 11x minus x to the 1/2. So you get f prime of x equals 4x squared minus x4 times 11 minus 0.5x to the negative half plus 12x to x squared, 12x squared minus 4x to the third times 11x minus x to the 1/2. In the third problem, you have f of x equals x plus 5, there's a typo on the screen, times 7x to the fourth plus 7. So f prime, or the derivative of f, equals x plus 5 times 28x to the third plus 7x to the fourth plus 7 times 1. Now we're going to be looking at the quotient rule. With the first problem, you have f of x equals x plus 5 divided by 2x plus 4. So f prime equals 2x plus 4 times 1 minus x plus 5 times 2 all over 2x plus 4 squared. And then you can simplify that and you'll get negative 6 over 2x plus 4 squared. When given a table like the one shown, you first find the derivative of the function as normal and then plug in the corresponding values. In this problem, there's a typo, which p should equal g of x over h of x. So p prime equals h times the derivative of g minus g times the derivative of h all over h squared. P prime of 2, you plug in the values and you'll get negative 2 times negative 2 minus negative 1 times 4 all over negative 2 squared. P prime of 2 will simplify and give you 2. In our last practice problem, it's hard to see what is being written, but there's a product rule within the quotient rule. So q prime equals f times g times h prime plus h times g prime minus g times h times f prime all over f of x squared. The end.